Hey there, I'm Frank Mitchell. On this channel, it's all about helping you understand your car and keeping it running the way it should. Whether it's routine maintenance or solving those tricky problems, I've got you covered. If you find this useful, give the video a like, hit that subscribe button, and be sure to watch till the end. You might learn something that saves you time and money. All right, let's get
The
started.
hybrid car market brings together different types of mechanical configurations based on a scheme where a thermal, diesel, or gasoline propellant, an electric propellant, and an electric energy accumulator appear. Based on the characteristics of the electrical equipment, there are three classes of hybrid cars according to the architecture of the mechanical system: MHEV, microhybrid, light hybrid, mild hybrid, or mild hybrid cars. One of the big problems in choosing which type of hybrid car is of interest is to know, apart from distinguishing, the different types of hybrid cars that are of interest. This dilemma is not helped by the name used to refer to the same type, especially when there are, in turn, two subtypes in this group. Microhybrid cars, also called mild hybrid or, when not, mild hybrid, are those vehicles whose conventional thermal engine is associated with another electric motor generator and which, in turn, is linked to a 12 or 48-volt battery, hence the 12 or 48V light hybrids. 12V or 48V light hybrids. These cars differ from each other not only in the power of the aforementioned electric motor generator but also in the storage capacity of the battery. While the motor generator of the microhybrid car can generate little power, from a few horsepower, such as the 8 kilowatts per 11 horsepower systems, to others whose contribution is practically that of a combustion engine of moderate power, 60 kilowatts per 82 horsepower, the battery that equips the hybrid system can offer a capacity of 12 or 48V. In any case, these systems are installed in order to reduce the consumption of the main engine, either diesel or gasoline, assuming the role of engine generator of electricity of auxiliary systems such as starting, exterior lighting or interior lighting, climate control, information, and entertainment, in such a way that the main engine is free from that function, thus avoiding fuel consumption in the generation of electricity to provide such systems as it has traditionally done through the alternator. It should be noted that, in mild hybrid cars, the engine generator of the electric system in no case replaces the main thermal engine. Although it is possible for the car to drive with the gasoline or diesel engine turned off at specific times thanks to inertia, which is known as sailing under sail. The vehicle then keeps the electrical system switched on from the energy generated by the electric motor generator, which allows the traditional engine to be switched back on when necessary and almost immediately. The 12V microhybrids have been the most economical solution for many manufacturers to not only improve the homologated amounts of consumption and emissions, but also to make their cars classified with the C label as ECO cars and to show off the green and blue sticker of the DGT model from Toyota. CHR 28.200 euros. Compare offers Kia Niro PHEV 27.650 euros. Compare offers Renault Clio 14.910 euros. Compare offers Hyundai Ioniq 26.445 euros. Compare offers. Similarly, 48V mild hybrids improve both fuel economy and exhaust emissions, but they can also support the gasoline engine at times when additional power is needed, but in no case does the engine generator replace the traditional engine as it has no motor capacity to do so. This means that the range of mild hybrids, light hybrids, or mild hybrids is 0. HEV, hybrid cars, combined hybrids, or full hybrids, with the distinction by its acronym, hybrid electric vehicle, as a sign and the first meaning as the most widespread. When we talk about hybrid cars, we refer to mechanics that are composed of a main thermal engine and an electric system with a propellant that has the capacity to propel the vehicle by itself and with an accumulator that manages to regenerate autonomously the electric energy it requires, without the need to be connected to an external recharging point. Technically, MEVs are self-recharging hybrids, since the motor generator is responsible for producing the electricity stored in the battery, but HEVs are vehicles that, in addition to this, the motor of the electric system moves the car by itself, while mild hybrids do not. The purpose of the hybrid car's electric motor is twofold: to move the car in certain circumstances and to support the thermal engine when necessary. In the first context, the driving action of the electric motor of a hybrid car is relegated to movements such as starting the car, parking, or for example, traffic lances such as restarting after traffic lights or other signals that involve stopping the vehicle, as also happens in traffic jams, etc. Electric mobility is usually carried out through the intervention of the vehicle's control unit, which evaluates and determines the appropriate engine for the situation. Although it is true that most hybrids have an EV mode that can be selected by the driver and that will start up as long as the same control unit considers it to be appropriate. However, the range of a hybrid HEV is very limited. In these contexts, it does not usually exceed, at most, 2 or 3 kilometers in regime as an electric mobility vehicle. The other major contribution of the electric mechanics of a hybrid comes from its assistance to the traditional powertrain. In these cases, depending on the architecture of the car itself, the electric motor directly assists the thermal engine or is responsible for traction by sending its work to the wheels, improving consumption and thus reducing gas emissions. PHEV, plug-in hybrid cars. The plug-in hybrid electric vehicle, hence the acronym PHEV, are hybrid vehicles that, in addition to being able to recharge their battery on the move, as HEVs do, also have an external recharging system. In fact, the concept refers to a car that is a hybrid because it has two different drive systems, one of which is electric and can be recharged autonomously, but also externally. When these hybrid and plug-in cars obtain energy by connecting to an external electrical outlet, they accumulate this electricity in capacitors of greater capacity than those fitted in self-recharging hybrids. This fact allows them to offer greater range and even allows the electric propulsion to replace the thermal one during a considerable period of time. If we talk about the autonomy of PHEVs, we must understand that, not too long ago, those with the longest range reached 20 or 30 kilometers. Today, the longest range plug-in hybrid cars have a range of 100 kilometers. The greater ability to circulate as a zero-emission vehicle is the quality that has taken the DGT to establish the classification of hybrid vehicles, including plug-in, which have the ECO label, and those that do with the zero. The threshold is set by the mark of 40 kilometers of autonomy in EV mode. Cars with less than 40 kilometers have the blue and green. Cars that can travel 40 kilometers or more without using fossil fuels receive the blue one. In conclusion, the autonomy of hybrid cars is significantly influenced by the architecture of their drive systems. By understanding the interplay between electric and internal combustion engines, we can appreciate how different configurations impact fuel efficiency and overall range. As technology continues to evolve, hybrid vehicles are likely to become even more efficient, offering drivers the best of both worlds. Embracing these advancements not only enhances our driving experience but also contributes to a more sustainable future. Thank you for watching, and we hope this exploration has provided valuable insights into the fascinating world of hybrid automotive technology.